Welcome everyone. This is another episode of Game Theory. I forgot to write it on the screen this time. I will put a G and a T. Welcome. It's going to be fun. We're going to go over some awesome stuff I haven't really planned. That's about it.
Good stuff. I'm really interested in this video that is on your recommended YouTube channel, which is like a game theory video about Portal. Did you see it? Like warning, science. There we go. Portal's killed science.
Killed science.
It's a long one too.
I think we're going to have to, instead of doing our planned game theory thing, we should just collectively watch this video and record it. People actually do that, you know, they do like recorded reactions.
Yeah.
That's kind of weird though.
But I've never understood people that want to view reactions videos like that. I mean, it's kind of weird, isn't it?
Yeah, I don't know. I feel like, well, okay. I'm getting this idea of just recording everything that I do. I just want to do it. Like, it's free, so I can do it. Like, anyway, but that's not really game theory. So, last week, did you check out the Gambit software? Because that was something that I really wanted to look into.
No, I've been reading a little bit only, but not.
Awesome.
I didn't do the Gambit. Did you?
I did the Gambit software, and I didn't do as much of the reading. So this is a perfect give and take. So which one do you want to do first? Do you want to go over some of the chapter, or do you want to check out, should I guide us through the Gambit software?
Maybe we can do like a little recap and explain some things to Saraswati and see that we're all sort of at the same page.
Very good.
Explain everything to me, please.
Yeah, so what do you want to know? What do you know? Have you read the book? Have you watched our videos?
I've watched like a little bit of the videos and I've read a little bit of the book, but these things, I mean, this is pretty far out of my depth. So I'm kind of just like, but I do like being a fly on the wall and I understand like little bits and pieces, which is handy, but yeah, I don't know how, it might be a lost cause. But maybe not. You guys can just do your thing and I'll listen along and ask questions if I have them.
Sure. Yeah, that could work. I mean, the basic concepts are the ones that we have talked about before. It's like Nash equilibrium and how to find them, and doing derivatives to find the maxima of functions and stuff like that. And we have some pretty slick methods for how you can find the Nash equilibria given a matrix of the game that you're considering. And maybe Carl has even the software that allows us to find the Nash equilibria automatically from such a game matrix. But we'll see about that. We're currently on like chapter 5. I've been reading a little bit more in the middle of chapter 5, but I wasn't able to get much further than last time. So yeah, we can talk about those experiments or those exercises a little bit later.
Yeah, I think that maybe it would be, so do you recall the difference between a mixed strategy Nash equilibrium and a pure strategy Nash equilibrium? Basically, the answer is you probably have some kind of recollection. In one, you kind of like choose your tactic the whole way, and you're always going to like use this strategy. In the other one, your strategy consists of a bunch of different possible choices that you could make, and you basically roll the dice before you make your choice. And so the reason why I bring this up is because I actually have a bunch of examples that maybe it makes sense to go through in the Gambit. Like, for instance, I just like put together the prisoner's dilemma stuff and like a couple other things, and it's actually really easy to do this. So do you think that would be a good little kind of, we can go over a lot of topics, I think, by running through the Gambit software?
Yeah, definitely. That sounds like a good idea.
Cool. So first, this is the prisoner's dilemma. So as you can see, so this is the Gambit software. It's kind of, there's a dependency, by the way. If you're trying to install this software, um, and it like doesn't load, then just run it in the command line, and it'll come up with an error. And I think there's like something you need to install. Yeah, libtiff, that you need to install to actually get it working. But anyway,
Very cool.
yeah. So this is so here we have like our normal prisoner's dilemma. The red is for player one. You can change the player's color with like that thing. Oh, that's a terrible color. And the blue is player two, of course, right? You can actually add players right here. And here you can just compute Nash equilibrium of the game. And so they give a couple different methods of computing, but just recommended. Boom, we come out with the answer. So you don't actually have to learn anything in game theory, it turns out. You just tell the computers have the computers do it for you. And so this is player one right here, choice two, and then this is player two, choice two. And so if you remember the prisoner's dilemma, there's player two. There's choice two for player one, choice two for player two, and they both get 0 because, then they don't get the 1-1 because of this tempting high score right there. So there's the prisoner's dilemma. Does that make sense? Any questions on it so far?
Not so far.
Cool. So I did another example, which is a 3-person game. I don't think I did it right, but whatever. Because I didn't really get the answer I was expecting to get, and I'm not quite sure why. So I clicked add a new player. So if you see in this old game, and I click add a new player, it'll like add a third column with payouts. And then you actually have to hover over this, and it says add strategy for the player. So at first it doesn't it assumes that the player doesn't actually have a strategy or any choices, so you can add a strategy. And so this is what I did to get the 3-player game that I just created. And let me go back to what I had here. So this is actually from the book. I can probably find the spot. It is right here. This is what I was trying to solve, right? And I'm curious, Martin, if you see where I'm wrong, let me know. So far, so this is the basic game. Is we actually went over it in our last video. You have 3 players, and this is the payout matrix if player 3 chooses to go up, basically choice 1, and this is if player 3 chooses choice 2, right? And then these are the payoffs for each player, and it goes, player 1 is 1, player 2 is 2, player 3 is -1, right? So this is exactly how I tried to represent it here. So player 1 to -1.
But it looks like you have flipped player 2 and 3 in the payouts. So you have player 3 as green, but player 3 is also in the middle. So maybe that's why.
Oh my God! Thank you. That's right. Oh boy. Let me fix that. Oh God, no. No, what happened?
Did it crash or did you close it?
I Control X somehow closes every single Gambit window. Are you serious right now? Son of a gun. Okay, that's okay. So by the way, it starts out, it's fine. It doesn't take long to make these. So this is how you create a new strategic game. And this one gives you an extensive tree game. So we can go over the extensive tree, and it's actually really easy. So I'll just recreate it really quickly. It's actually super easy. And add a strategy, and then I will fill these in. I'm going to mute because I'm going to be really noisy if I don't.
All right.
Oh boy. Do you know if I made any mistakes? Does it look like I made any mistakes? Well, we'll see if I made it. I can compute the Nash equilibrium and we'll see. Boom. Did I get it right? Maybe not. So I think the answers are here. Oh, sweet. I think it looks like I got it right, almost. It's like close. Yeah. That. Yeah, there we go. I mean, it's like it's a little off, right? Right, Martin. Do you believe that I basically did it right?
No, I mean I don't see it being correct.
It's like close though. You know, I mean, it's in the ballpark. If you look at the, you know, if it rounds weirdly, right? I don't know what their rounding is doing. Maybe I'm just overly hopeful.
Yeah, I mean I don't think that we can assume that this is like a correct thing, but I don't know. Especially since they did it with Gambit also. I think that would be weird. Can I see the matrix again? So where do you put in the other choices for plate 3? Oh, okay, it's like that. Uh-huh. Yeah, so Carl, I don't think that the way you put them into the matrix is really correct here.
Like the structure of the matrix or the typing in?
Like the -1 that you have marked right now, that should be player 3 plays down, player 1 plays up, and player 2 plays up. Don't you think?
Player 3 plays down. Player 1 plays up. Oh, player 1 plays down and player 2 plays up.
No, player 1 and 2 play up, and player 3 plays down.
I think this is the one I was trying for that row. I was trying to do this.
Yeah,
right?
and I don't think that is the one you should have there.
So this is player 1 playing down.
Up.
That's player 1 playing up?
Yeah.
Why? Because
it's
one
still
thing?
in the one column. Yeah. Or
So
the one row.
But maybe so do you think it's because this second column or in the second row is for player 1? It's like a player 1's thing instead of player 3's thing.
Yeah.
Then why is it that when I press add what? So I clicked add strategy again. And now it gives me this, right?
Yeah. So now you have 3 options for player 3. Does it make sense?
Not quite. What do you mean? I have 3 options for. Okay, yeah. I have 3 options for player 3. Yeah, that makes sense. Oh, I see. Oh. I see. This is player 1.
Yep.
This is player 3. I totally didn't see the 1 and 2 for player 3 until now. That's
okay. I don't know if they were there until now. Actually, didn't they just appear?
I don't know. It just.
Somebody's gonna have to go back and check.
Yeah. Thank God this is recorded. It's for our subscribers and for our fact checking. Okay, cool. So that's a bug in the system. Thank God. Okay, that makes perfect sense. Thank you for it. That was a great catch without even having the visual aid of the software being correct. Okay, cool. So now it doesn't translate 1-to-1 with our with this thing, so it's kind of hard to input. But it seems like it makes sense, right? Like, should I try to fix it right now? Okay, I should, right?
Yeah, that's.
So what would be the translation of this? So it would be like this row and this row, right? And then it would be this row and then this row. Is that correct? If I were to do a 1-to-1 translation?
No, so the entire first row is where player 3 plays up. So you're going to do the matrix to the left, like that.
Okay, so this is still correct, right? The first row is still correct.
Yep.
Okay, the third row is, I mean, everything after the first row is wrong. Right?
Yeah. And the
so
second row is going to be
this, right?
no, it's going to be the top row in the right matrix.
Oh, the top row in the right matrix. Ah, yes. Okay, that makes sense. So it would be 1, 4, -2, and then 3, 1. Okay, and then this one is going to be, it's this, right here.
Yep.
So -1, 0, and then, oh, whoa, I told 2, 4, and then of course the last is the last.
The last one looks like it's correct, no?
Yeah, it is right. Okay, so let's see if we compute it and get the same answer.
Yep.
Oh
yeah.
my God. I am so lazy that I just was like, rounding error. Close enough.
Yeah, that was tricky to put in the matrix though. We're shifting a lot of things. But nice. So Gambit works and we function as well. That's good.
Yeah, and now we get to do the really fun stuff. So this is something that we just recently started going over, which is extensive form games. And so it's actually not hard to input them. And it honestly almost makes more sense. I don't know, maybe. So this is the game. I just put this in. I actually don't know if we have an answer for this, so maybe I should put in one that we have a solution to. Although we can actually check the solution because it's so easy. I'm pretty sure, right, for this one. Should I do this one, Martin? Do you give me a green light?
Mm-hmm. Sure.
Okay, so here we go. So all you need to do, you have your 2 players, right? And so you right click and you insert move. And so with 2 actions, right? Because we're going from player 1 to player 2 with 2 actions. So we want to do insert move from player 2, add a new information set. So this is important because it's going to, well, we went over information sets 2 videos ago. And yeah, so now we're at this point.
But it should be player 1 that makes the first move.
Is that, oh, you're right. Ooh, that was bad. Thank you. It is player 1 that makes perfect sense. Okay, so player 1 makes the first move, and then player 2 makes the move. Oopsies. And add a new information set. And the reason why is because we don't know this information, right? And I guess we don't even have a choice in this case. Oh, that's confusing. Because we don't. So now, okay. So it's starting to look similar. And this is where for player 2 we choose the same information set as we just created here, right? And so that creates this like the dotted line. And I guess the intuition for that is that you will always be at a new information set if that's the only time that you would get to this choice, right? You'd make the same choice. Like the information set here, if I only had this, for instance, right? For me to make this choice 1, 2, and 3, there's only one path that I could go down to get to that choice. But now because I have this extra move at the same information set, it has to have the same number of actions. That's why they gray that out. And I did it for the wrong player. Same number of actions and same information set. because it's at the same information set. Anyway, and then here it's super easy. You just like put in the matrix, the information. Cool. And then you can just calculate it. Calculator. Boom. Pretty easy.
Cool.
Yeah. So it's a like, you know, I actually really like this way to lay out games. It really just seems pretty nice.
So does Gambit also allow you to have the payoff function be a continuous function?
Oh, that's a good question. I actually am not totally sure. Dominance. Ooh, tools, dominance. Okay, I just started playing around. Oh, strictly dominant. This is cool. All actions are shown. Anyway, I don't know, to be honest with you. I presume that they do. I'm not sure if they do using the GUI. I know that Gambit actually is a Python library or has a Python API. And so what they recommend in the documentation, which I believe is somewhere here. Yeah, here we go. So this is the Gambit documentation on the graphical interface, but it's noted that you're supposed to, for like real use, you would use the Python interface to the Gambit library. So you could I'm sure declare the kind of payout that you're talking about there. Continue.
Okay, cool.
All right. So does that make sense?
Yeah.
Cool. Should we go over the chapter stuff?
Mm-hmm. I can share my screen.
Awesome.
Yes.
Market capitalization.
So maybe it makes sense to, like, I think we talked about Kernout, which was the economist that showed that there is a Nash equilibrium in which supply and demand are met pretty nicely for two firms making things. Let's see if I can walk you guys through a generalized example. Here we are of the Kernout model. So Kernout was an economist or a game theorist, and he did a few investigations on supply and demand situations, and firms are producing goods. And so in this scenario, we have two firms that are trying to maximize their profit, and they are producing a good at a certain cost. The cost is a function of the quantity of the goods that they're producing, and the price is also a function of the quantity, because the demand varies with the quantity. And so it is a slight generalization of a previous example that I think I talked about a little bit last week. But it's still pretty limiting in the conditions put on the cost and the demand, or the price. The price is set to be equal to the demand. So I'm gonna use them synonymously here. So the conditions on the cost and the demand functions are pretty strong, which is that the price function as a function of the quantity, you can derive it 2 times, and it is non-increasing. In other words, it's probably decreasing. And concave, meaning that the second derivative is negative, and that the price is positive when you begin, and there's some quantity at which the price is 0. Okay. And conversely,
why is the price the demand, you said? Like you're using them synonymously.
That's the way they define the price. They actually just set the price equal to the demand here.
Okay. Oh, it's the demand with the okay, yeah, of the and
so
Q is the quantity, right?
Yeah, exactly.
Okay.
Cool. All right. So yes, and so conversely, the cost function is also derivable 2 times, is strictly increasing, which is even a stronger condition than non-decreasing. So strictly increasing meaning that it's strictly larger at every higher quantity, and convex, so the second derivative is positive. And that it is increasing slower than the price is at, or yeah, the price or the demand is at 0.0 initially. Okay, so those are a lot of conditions, but then in this particular scenario, and where we have the payoff functions for the 2 different firms as just the quantity that the firm produces times the price minus the cost that it takes to produce this number of quantities, and similarly for the other firm, then we can find a Nash equilibrium, and it is going to be the quantity such that this equation is 0. And so I'm going to walk you through the way to solve this. And the first thing that we can notice is that these equations look pretty symmetric. And so it's not very surprising that the Nash equilibrium is the same quantity for both firms. In particular, they have the same cost for producing this quantity. So C here is the same thing, and
that's a big if, basically, or that's a big assumption that 2 firms will have the same cost producing.
Yeah, definitely. But so to get the Nash equilibrium out of these payoff functions and the whole scenario that we have set up, we do what we always do, which is to derive the utility function based on the variable that you can control. So the different strategies for the first firm is the amount of quantities, or the quantity of the goods that it can produce. So if we derive the utility function of the first firm with respect to the quantity of the good, then we're going to get this following expression. So we can see that we have inserted some little marks here to note that we have taken the derivative of this function. So here the Q1 disappears, and we get this thing corresponding to that. Then the inner derivative, which is here, and then just the derivative of the price, or the cost, sorry, which is here. And when we set this to 0, we are trying to find the max points, or more generally, it gives the extreme points, and then we have to check that it is indeed a max point of this function. And similarly, for the second equation, for the utility function of the second firm, we get absolutely the same expression. And if we subtract these equations, if we subtract equation number 2 from equation number 1, then we get the following expression. And since the cost is always positive, and in particular
it's increasing, always increasing, right? And never zero.
Yeah, exactly. In particular, it is increasing. And the demand is decreasing. Then we see here that if it were the case that this turned out to be non-zero, then we would have 2 positive things here that would add up to 0, and that's impossible. And similarly, if it was not positive but negative, then we would have 2 negative quantities adding up to 0, which is also impossible. So it must be the case that the 2 quantities are the same.
Okay. So essentially, this is saying that the quantity for both firms has to be the same, because if it is not the same, then it would break the laws of like a always increasing cost and a always decreasing like demand.
Yeah, or at least it would. I mean, it wouldn't break those requirements, but it would mean that we wouldn't have a Nash equilibrium because we wouldn't have these 2 equations satisfied.
Okay, so it has to be 0.
Yeah, the difference between the 2 quantities has to be 0.
Okay.
So they have to be equal. And that means that the equation that we're really looking at, if we just, substitute Q2 for Q1 here, is, or rather substitute both of them for just a Q, is this equation. And since we haven't defined what the demand function or the cost function is, this is our final answer, basically. That the quantity which is a solution to this equation is the quantity that gives us a Nash equilibrium for this game. And so if we get an example of a function, so with a price function that looks like this and a cost function that looks like this, then we can just plug those numbers into this equation, and we get a solution that the quantity that you want to produce is a certain number.
Nearly pi.
Yeah. And so, yeah, that's how you can model kinds of scenarios. It's a that goes through the of just deriving the utility function with respect to the variable control in order to get the Nash equilibrium.
Cool. That's awesome.
Yep.
Is and the chapter goes on to describe like more continuous examples and derivations, and I assume that there is a like maybe not, would it be still a linear programming model for like solving these things?
I mean, no, not really, because you're not really solving a linear system of equations. If you were to do that, you would have an infinite number of equations, and since we're not doing that, I mean, we are doing the derivative of things instead, where we have the utility function specified as an equation or a function of something. And that means that you're going to be solving a system of equations, but they're not necessarily going to be linear. So you might need to do some differential equational reasoning.
Cool. Yeah. And yeah, I have to finish this chapter. I definitely get a little bit more. I think that I have the finite stuff down relatively well, but I definitely don't have like the continuous stuff down. And I will research for next time whether or not Gambit you can like input a continuous payout function, because that would be really cool if you can. I mean, I'm sure you can. I have a thing.
Yeah, I didn't finish chapter 5, so there's no rush really to, or I mean, you shouldn't feel like you're behind. I guess that I am the person that is least behind, and I haven't finished chapter 5. So I think we should read that more. There is something which he calls duals that are happening throughout the rest of chapter 5. Which is like includes stuff like auctions, battles
Nice.
between two companies and stuff like that.
Yeah, one thing that can definitely. Did you see? So Vlad put out a post recently on ENS, and he does a little bit of like quick little analysis of different DNS distribution like schemes and their essentially the squatting problem that we have for DNS, right? So you always have a like there's going to be the cost of squatting that you have to make the cost of squatting higher. Oh yes, this is what it was. The way that ENS currently works, right, is that to buy a domain, you essentially lock up Ether, and then when you want to give up your domain, you give back that Ether, right? So there's an auction that goes on for who's willing to lock up more Ether. And so that's better than kind of just paying for the domain, because it does, but it doesn't totally fix it, because it essentially says that a squatter would just have to value the cost of illiquid Ether capital, right? More or less than they would gain from squatting the domain. So anyway, point is that I may be getting that wrong, but that is an interesting kind of use case to think about, especially regarding auctions. This is where it all comes back, hopefully. So anyway, do you want to, Martin? Are you still there? Maybe he's just really still. Oh no, never mind.
He's gone. Is this like DNS spying with Ether in a different DNS context, or is this just buying DNSs? Are you still there?
I'm still here.
Oh, is this like same DNS that we're like same DNS worlds just with Ether?
So it's basically registering names like DNS, the same kind of idea for normal DNS, but instead of using the kind of domain name service like hierarchical entity that exists on the main internet, it would be registering it on Ethereum, and then these kinds of things are essentially valid within MIST browsers and whatnot. And the real use case for all of this is that you're able to register a domain, let's say like carlflirsch.eth, and then if someone wants to send you Ether, all of the wallets, you'll start being able to type in like send 10 ETH to carlflirsch.eth, right? Instead of 0x57892113.
I see. That's cool.
But so it doesn't give. I mean, it's.
Oh my god, you're
but,
like in paradise. Get out of here. Oh my god, it looks so nice.
Yeah, it's pretty nice. So it's going to be used in the Mist browser. That's nice. I didn't know that. Because I'm guessing that there's not really a way for it to use, like, I mean, most of them look like URLs, but you won't be able to like type it into your browser and get to some DApp though, would you?
Yeah, I think that MetaMask is not going to be able to like shim URLs because I just don't think that Chrome web apps allow you to do that, because that would be a little bit terrifying if they did.
Yeah, but you could still have like you go to ENS and then you type in a domain and it forwards you to a web page which the domain corresponds to. So you're still using the old DNS, but like you're trying to decentralize through the already existing infrastructure.
Yeah, you can have a gateway, right, where you're like, go to gateway.ens.com and just /carlflirsch.eth or something. But and so it presents one of many problems that essentially require some kind of economic game theoretical analysis to do it right. The current scheme for registering domains is not perfect by any means, and so we really do. I mean, like this kind of problem that we're coming up with, like learning about how auctions work, learning about how to actually like model these games out. It's going to be required for like every project, which is just, I mean, it's more validation. It's like more exciting stuff.
Yeah, I think it's nice that they burn Ether also. They burn 1% of any bid that you make, which makes everybody's ETH more valuable, which is nice.
Yeah, exactly. $22 is not enough. Come on, it needs to be at least 1,000.
Eventually.
Yep. Okay. So next week, I'm gonna try to finish chapter 5, or like get 90% the way through it. I'm gonna look into Gambit and also do 100 other things. But yeah. Does that sound good?
Yeah, it sounds good, but you shouldn't kill yourself, Carl. You should take some time to meditate also and be sane.
Yes, I agree. And also time to go down to Miami and chill with the palm trees.
Girl.
Yep.
Sounds good.
All right. Well, thank you. That was fun. Have a wonderful week.
You guys too.
Thanks, guys, for letting me hang.
Bye.
Peace.